All right, hope everybody's doing well. And yes, it is a fantastic afternoon out now. Um, it's warmed up and it's sunny, and it's a perfect moment to be doing Java programming and threading. So, comments up front. First of all, I finished grading PA4. I posted feedback for that. For a lot of people, the feedback was simply something like, fantastic work, this is great. Because a lot of people nailed this perfectly. One thing that I saw in some people's submissions was make sure that you're only painting from the paint method. Okay, some people figured out how they can get a hold of the graphics context from another method and then use that to do things like draw lines in the mouse handler. And that will look like it's working, but it's really not. And you can tell it's not working because if you try to resize the window just a little bit, all of those lines will disappear. Or they may appear in the wrong place. Or after doing that, you may find that clicking to display a line makes previous drawn lines disappear, and so on. And those are all artifacts of two things. One, not doing all of your painting in the paint method, and two, not calling super.paint in the beginning of that method. Okay, and you really need to do both of those things to have a rock solid display. Which means if you want to draw multiple lines, if you want to do more than just one drawing inside your paint method, you've got to store all the information that you need to say, hey, here's where all the lines should get drawn. Okay, so that's where we're using an array of boxes, for example, or some people used linked lists and so on. But drawing outside the paint method is generally a risky thing to do, and it's probably not the right thing to be doing. And if you call the repaint method in the beginning, the super paint method in the beginning of paint, if you're not drawing everything you need to, it'll be obvious because super paint refreshes. Alright, so one person is telling me that they're not hearing any audio. So let me stop my screen sharing. Let me do this. Can anyone hear me? Okay. So one person can hear me. And one person cannot. Alright, hold on. Let me pause. Alright. So I'm recording again. So make sure you do all your drawing from the paint method itself. Okay, and make sure you call the super classes paint method in the beginning of your paint. If you do those things and your display looks good, then it's probably going to be nice and stable. Alright, get rid of this. So, any questions on PA4 or what we've talked about so far with PA5? I'm going to talk about threading. I'm going to talk about client-side network connections, and I'm going to talk about doing these things from Eclipse. Alright, let's drop into Eclipse. So let's talk about networking a little more first, because we addressed this from the server side, but let's do this from the client side. Do our version of Telnet. So we'll make a Java project called server, and we'll make a single main class. So we'll put a public static void main in there, and I'll just call this server main. So we're going to have our server socket, we're going to have a socket. And we'll have a scanner. And I'm going to server soccer. I'm going to go ahead and do these imports. And I'm going to be really lazy about my try-catch blocks. I'm going to put everything inside a try-catch block just in the name of efficiency. But don't do this, okay? But I want to do this to sort of keep the core code together in one place. So we'll do one try-catch block. So we'll do ss equals new server socket. And we'll just do port 1111, and then we'll create a scanner. And we'll read from the input stream of the socket, and we'll use that to construct our scanner. But before we do that, we have to accept a connection. So this waits for a connection request, and then it accepts the connection request, and then it gives us a socket that we can use to talk to the client who connected to us. So we'll get an input stream from that socket that'll give us a scanner, and then we'll do our usual while loop. Alright, so that's our whole deal, and we'll put this all inside a try-catch block. Alright, and I have an extra, that's our try. Alright, so there's our main method, okay? This is a generic server, keeps receiving from port 1111 and writing to standard out. So if I telnet to localhost 1111 and I say hello there, my code will say I received hello there from client. Cool, goodbye. And then when I break out of my client code, this loop terminates because the has next line comes back false. Alright, so let's make the client version of this. So let's make a new Java project, and I'll call it client. And let's make a new Java class, which I'll call client main. And I'm going to rip off a bunch of my code from the previous one. So I'm not going to need a server socket because the client side just creates a socket. Okay, I'm going to have a print writer though. So I'll import that. And so to create a socket, what we're going to do is new socket. And socket can be constructed with two arguments. The first argument is the machine to which you're trying to connect to. Okay, I'm just going to use localhost. This can be either the network name of a machine, or it can be, you know, something dot something, inside quotation marks. And then I'm going to put in the port number, which is 1111. And that can throw all kinds of exceptions, but assuming it succeeds, right, then I have a socket just like I had over here after I called accept. Okay, it called accept, and that gave me a socket which was connected to the client. On the client side, if I construct a socket, this will be a socket connected to the server. Okay, which server? The one listening at this port on this machine. So I'm going to create a print writer. And I'll construct a print writer using that socket's output stream. And so I'm going to write a loop here that just reads from standard in and sends to the server. Okay, so I'm going to open a plain old generic scanner on system.in. And then while that has input available, I will read that next line and I will send it to the server. So I'm going to say pw.println buffer. So we send that to the server. And we're going to always call flush to force the output to happen right away. All right, so making a socket connection to the server, getting a print writer so we can send things to the server with print line, and then opening up a scanner on standard in. And then in this loop down here, I'm just going to say read a line from standard in, send it to the server, and just keep looping over that. And I'll put a prompt in here. Which just says enter something to send, just so we know it's waiting for us. And we'll put that at the bottom of our loop too. Alright, so what I've been suggesting is go into your Eclipse workspace. So for me, it's called all workspaces, and in there, you know, there's a server in the client project that I had. So I'm going to go into my server, I'm going to go into the bin area, and I'm going to make a new window over here for my client bin area. So when I want to run my server, I can just say Java server main, and that's running over in this window. And over here I can say Java client main, and it'll say enter something to send. And I can say hello world, and it comes out on the server side, received hello world from client. Cool. And then when I'm done, I'm going to hit Control D, which should signify end of input. And my program exits, and you can see the client side also, the server side also exited. Okay, and this is if you have access to a terminal window, a DOS shell, anything with a command line prompt, I think this is the smoothest way to develop your code when you're wanting to run your program twice or run two programs, have one be the client, one be the server. It's easier to do it from two different windows like this. And if you do this in conjunction with Eclipse, it's particularly nice because, for example, I can say, let's put a print message here at the end. Right, to have the server say goodbye. And you know, there's a little asterisk up here saying that I've made changes to this. All I have to do is hit a Control S to save it. And now, when I run my code, I'm always going to have that new version, because when you save your code, it automatically compiles. So now if I hit Control D, my server side says goodbye at the end. Okay, that's that line of code that we just added. So this is a really rapid development cycle. Yeah, I'm on Ubuntu, but this should work from pretty much any Linux distro. And like I say, even if you're in Windows, DOS is still a thing. And you can open a DOS shell and you can run the Java command from there. You just have to, you know, CD with the backslashes to get to the right directory. But I think DOS has command line recall at this point. And so anytime you want to rerun, just, you know, up arrow and rerun. Okay, but you can do this from inside Eclipse. So let's look at how to do that. And I went through this a little bit in the morning class, but it didn't work exactly the way I was hoping. So let's go through this in Eclipse and see how we can do this. Now I'm in my server main, so if I hit the run button, that'll start running my server. And I can go to client main and I can start running the client. And it says enter something to send. And I can say hello server. And suddenly that window disappeared, and now I'm seeing a window that says received hello server from client. Well, if you look up here in the top left of this, this is saying server main. Okay, this is the main window for my server code. Doesn't matter what I've got highlighted up here. Okay, this is the main window for the server code. But there's actually two of these console windows right now. So if I come over here, I can say display selected console. I can switch to my client main window. There's my client main, which is saying enter something to send. So here's message 2. And it switched back to my server main, and there's my response from the server. Okay, so I have access to both consoles, but it's switching back and forth automatically on me, and that can be kind of confusing, and switching these is sort of awkward. So the window next to it, which says open console, I'm going to click on that and just say open a new console view. And now I've got two consoles, one up here and one down here. And this one up here is coming from client main, and this one down here is coming from server main. So here's a third message, and I can send that. But now both my windows have switched to the server view, right? And I can switch this one back to the client view, right? But that's kind of a pain. So you can pin a window to a particular console. So let's see where I do this up here. So if I hit pin console up here, that'll leave this one as the client. And down here, if I hit pin console, that'll leave this one as the server. So now I can say hello, this is better, I can see what is happening. Okay, and you know, you can drag these things out of here if you want and put them side by side and so on and so forth. So you can spend a while setting that up and make it the way that you want, or you can, you know, go with Unix shells, whatever works for you. But figure out something so that you're not fighting yourself. Okay. Now for you, the net.dot program is one program. You're not going to make two separate programs. It's just going to be one program with a radio button pair to choose whether it's the server or the client. But you're still going to be running it twice. You're going to run it once and say I'm the server. You're going to run it a second time and say I'm the client. You're going to start the server, you're going to connect the client, and then you're going to want to, click on the different windows and maybe see some console output if you're doing debug information and so on. And you don't want to be spending your time going back and forth and clicking from one console to another and trying to figure out what you're looking at, okay? It's extra work, it's extra fighting things that you don't need when you're trying to develop your code. So find a setup either like this, or with a pair of windows at the console command prompt or something that that makes sense to you. Okay. All right. So networking wise, right? This is all that's involved in doing the client-side connection, right? Just create a socket instead of a server socket. Give it the host name, which you're going to get from a text field, right? The port number, which is whatever I said the port number was in the assignment. And then, make the print writer for writing to it, make the scanner for reading from it, and it's business as usual. All right. So let's go on and talk about threads. And by the way, so let me stop this. Actually, I should have. Okay. Anyway, if you get your window in some strange view like this, right? Sometimes you can drag these and rejoin them. But easiest way to undo this, just go to Window, Perspective, say Reset Perspective. That puts you back to the setup that you had when you first started. Which for me, I'll just close out these. And then I've got my editor window here, I've got my console down here on the bottom, and then packages over here. Alright, so let me close these out. And let's see. Let's go back onto the command line. So let's talk about threads. And if you watch the video, you've already got the gist of this. But let's play around with threading. So the basic idea of threading is we can run more than one process at a time. Okay, in Java we can create multiple processes and have the code in those processes execute in parallel if we like. And we do this by creating a class that implements what's called a runnable. Okay, and we're going to do this by extending the thread class. So let me make a main method here. I'm going to make a class called myThread. And I'm going to create a myThread1 and a myThread2 and a myThread3. Alright, it's going to do a class myThread, and it's going to extend a thread. Alright, so thread is a built-in class, and the main thing thread does for us is it lets us create a process which will be run in a separate execution context, okay, a separate process. So what does this look like? We're going to make a process called run. Okay, and let's do this. Let's just print out the numbers from 0 through 100. Okay, but let me add a wrinkle to this. Let me set this up so that when I construct my thread, I pass an identification to it. So let's call this Mo. Let's call this Larry. And let's call this Curly. Alright, so we're going to name our threads. And so I'm going to make a constructor. I almost said car star. That's bad. I'm going to make a constructor that we pass a string to, and we're going to save that string in a field called ID. Okay. This is who I am. And in our loop that we print, we'll print out our ID, a colon, and then we'll print out our integer, and then a space. And then we'll say goodbye at the end. Alright, so we'll construct a thread, we'll give it a name, we'll go into a loop where we print out that name followed by an integer, and we'll loop through 100 times. Okay. And this method is called run, so I can run this method as follows. I can just call the run method. And that's going to do exactly what we would expect it to do. Okay, so Mo ran 100 times, and then Larry ran 100 times, and then Curly ran 100 times. Okay, no huge surprise there. Instead of calling the run method, though, if we call the start method, something different happens. Okay, so what is start? Start is not defined in here, right? I've written a constructor and I've written a method called run. I have not written a method called start. Remember, when you extend a class, if you call a method from that base class, which is not redefined in here, you end up running the base class's method. Okay? That's exactly what's going to happen right here. So we're going to call myThread1.start, and then 2.start and 3.start. And start is a really special method in the thread class. When you call start, two things happen. One, a new thread is created, a new process. Okay, this is something like doing a fork in C. Okay, it creates a new thread, and then that new thread executes the run method. Okay, this is subtle. If I call run, all I'm doing is executing the run method. If I call start, I'm also executing the run method, but I'm doing it after having created a new process. Which means that when I make this call, new process gets created, that new process executes the run method. My call to start comes back right away, and now I'm going to call thread2 start, which is going to create another process, and that process will execute the run method, but this call to m2 start will come back right away. And then finally, my thread3 start will call the run process in a new thread. So if I compile this and I run it, right, I get something very different. So what happened? Well, Larry started off, printed out the integers 0 and 1, and then Mo kicked in, and Mo printed out the integers all the way up to 15, and then Larry came back in with integer 2, and then Mo with 16, and this continued until Mo printed out 25, and then Curly chimed in and printed out a 0, and then Mo 26, and so on. And then Mo got a good run here at the end from 51 all the way up to 99, and then said goodbye. And then Larry and Curly basically traded off, Larry finished here, said goodbye, and then curly finished up with its last batch of integers. Right? And the reason these are interleaved is because they are running in parallel. Alright? And if I run this again, we'll get something totally different. Right? In this case, Mo had exclusive execution up through 45, and then Larry kicked in. In this case, Mo had run until 27, and then Curly came in. In this case, Mo and Curly and Larry all started off together. Okay, this is nice because it's parallel, right? And we didn't have to do a whole lot of work. We just said go ahead and start these threads, right? It's convenient when we want multiple things happening at the same time, but it can be a nightmare to debug, right? Why? Because I run this and something breaks. If I run it again, it may work, right? Maybe something breaks when Mo, Curly, and Larry all start off with their first integer before anybody gets to integer 1. Maybe I've got a glitch somewhere. I run this again and that doesn't happen, right? Because Mo started off with the first few numbers and my code works great. And then I try it another day and suddenly it's hanging up or it's giving me a wrong answer. So it's very hard to do, you know, what I said is so important in debugging, which is pin down a test case. That can be difficult. If you've done Engineering 270, you did the interrupt lab where you had the blinking LEDs, and then you're supposed to flip a switch and one LED comes on for 2 to 3 seconds, right? That's a hard lab to debug because sometimes you have a problem but you can't reproduce it. Okay, that's classic with threaded programming. And so incidentally, what's happening with our main program? Let's print a message here when main is done saying main is finished. Right? Well, Mo printed out its first integer and at that point main was done. And our main program exited. Right? What happens after we print this? Well, you know, we exit. I can put a return in here. Right? And main exited before any of these other threads even started doing any output. And that's totally typical. Right? Sometimes your main program just sets things up and lets these other threads go off and do all the work. And this is what happens in Swing, right? If you go back and you look at your Swing code for, let's look at my dots program. Right, if we look at our main program for dots, here's the public static void main. Here's where it ends. Right here on this curly bracket. And if I print out a message saying main program exiting right before main exits, and I run my dots program, first thing I see is the main program has left. Right? But this is still, you know, viable and doing its thing and so on and so forth. So when we do things with Swing, we're already dealing with threads. Because what's happening is, you know, our main program exits, our mouse handler gets a click and does a return, so that exits, but our program doesn't stop. Our program is still running in the background so that when we click a mouse button, our code starts to execute, right? Well, that's because our code is running in a series of threads. And those are mostly hanging out in the background, but we've set things up so that when events occur, methods inside those threads processes should be executed. Okay, and this is the nature of event-driven programming. All right, so let's talk about what this has to do with PA5. So I've suggested you make a NetThread. And the main thing this class is supposed to do is manage the socketed communication with the other game. Okay. So here's your main program. And it's setting up the drawing board and initializing scores and whose turn it is and so on and so forth. And it's also managing those radio buttons, and it's managing the start button. Okay, so ultimately you're going to hit either start or connect. And when that happens, what you want to do is create this new thread that takes care of communicating with the other player. So I suggest passing some kind of identifier to your constructor to tell it, am I the server or the client? So when you hit the start button, meaning that you're the server, right, maybe you do NetThread. Let me declare this up here. Maybe I do NT equals new NetThread server. And maybe when you hit the connect button, because you're the client, I'll do NT equals new NetThread client. And in your constructor, you look at this argument and you do one of two things. If your argument tells you that you're the server, you create a server socket. Okay, bind it to whatever the port number was that I specified, and then accept connections on that. But if your argument to the NetThread constructor says you're the client, create a socket with whatever address is specified in that host ID text field, and whatever port number the assignment says. I think it's, I don't remember what it was. Right? And after that, whether you're the client or the server, you will have a socket that you can use to communicate with the other process, the other player. So then what do you do? So let's do a server socket. Or a socket. Make your print writer and your scanner. Okay, because we're going to do two-way communication. We're going to send and receive names. We're going to send and receive coordinates. So set up your print writer and your scanner using the socket.getOutPutStream, socket.getInPutStream. And then, pw.println my name. And then get their name is sc.nextLine. Right? So send a message out with your name, and then read from the socket, and whatever line you read, save that as the other player's name. And your other player is doing exactly the same thing. So what you're going to read here is what the other player printed, which was their name, and what they're going to read is what you printed, which is your name. Okay, so that's the introduction, that's the handshake. Now you know who each other is. And now you can go into your infinite loop. So while SC has next line, call next line. Okay, that gives you a string from the other player. And that should, if you're following the suggestions from the assignment, that should be something like the letter C followed by an X coordinate followed by a Y coordinate. So parse that out and then call, mouse handler or click handler. So parse out your X and Y, call your click handler, and you just hang out in this infinite loop forever. The reason you can hang out in an infinite loop forever is why? Because this is a separate process. Your main thread, started over here with your public static void main. It created this new thread, right? And you want to call the start method. Right, but this call comes back right away, and you can continue with your public static void main or whatever it is that you're using, to run your dots program. But while that's happening, this thing is sitting in a loop, and it's just waiting for something to come in from the other player. When it does, it means the other player clicked it in XY position. You just call your click code, and does exactly what it would have done if your friend had taken your mouse and moved it and clicked. Right? Your code doesn't know the difference. Whether that was you who clicked it or your friend who clicked it. So you've already written your code to take turns. First click is yours, the next click is your friend's, the next click is yours, the next click is your friend's, and so on. Right? So if you receive coordinates from the other player and you just call that same code that you were using in response to a mouse click, your code should work. Right? It should attribute that move to your friend, and it should update the turns appropriately. And then over here in your mouse listener, right, get your XY coordinates, send that to the other player. Right? Well, how do you do that? Well, one way is go into the NetThread. It has a print writer object, print line C plus X plus space plus Y. Right? Doesn't matter that this thread is in an infinite loop inside this run method, right? You have access to this object that's NT, and if you have access to this print writer object inside there, you can use its print line method. Alright, so the cleaner way to do this, though, is don't just start monkeying around with this print writer from here. Put some methods in here. I can make a method called send. Make it part of this NetThread class, and when you say send and you pass a string, have it take that string and then do pw.println text, and then do your pw.flush to force it out. Don't forget your flush. And now what you do over here is you just say something like, nt.send, and you send C plus X plus a space plus Y. And that's a little more sort of the encapsulation that we're thinking in terms of object-oriented programming. This is the thread that takes care of communication with the other player. This is the object we're going to use to send and receive. So when I want to send something, I use a method inside this class, right, this NetThread class. I use a method called send, and that takes care of knowing that, oh, I should use the print writer, and I should do a print line on that, and then I should do a flush. It's not going to be a problem for us however we decide to do it, but more generally, this could be a problem if I was doing something with the print writer in here, and while that was happening, I tried to do something with the print writer over here. Okay, and this is where we're potentially going to start getting into problems with multiple processes. Okay, should not be a problem for PA5 because this loop is only reading and we're only going to be writing. But in the spirit of trying to keep things clean and working towards being able to deal with more complex scenarios, let's do all the I/O from methods inside this class, right? So make yourself a send method which does the pw.println. Okay, and what we're going to talk about tomorrow are some of these ways that we can get into difficulties with multiple processes. So we'll talk about deadlock, we'll talk about live lock, we'll talk about synchronization of access to shared objects, mutexes, ways that Java has to deal with the synchronization, volatiles, and things like that. What font size should we use in the SLP report? Whatever works for you. Typically it's 10 point or 12 point. So I would go with one of those. There's no minimum page requirement, so you don't have to, do a really big font to make it look longer. But whatever you think is reasonable. I would not go smaller than 10 though. And I think most people are using 12 these days, so your choice. All right, any other questions? All right, well, enjoy the afternoon. I've got office hours from 3 to 4 if you want to talk about PA4 and such. Otherwise, have a good one, and I will see you tomorrow.